Hello everyone. So friends, in our previous lecture we discussed about the insertion sort and we saw the demonstration of the sorting algorithm. Now in this lecture we will see the demonstration of insertion sort algorithm step by step. So friends, here you can see that this is the algorithm to perform insertion sort. So let's say we are given an array having 5 elements which contains values as 5, 1, 9, 2, 10. So here you can see the values are in unsorted form. So let's see the demonstration of this algorithm step by step to sort this array in ascending order. So here the number of elements inside this array are 5, which are ranging from index 0 to 4. So friends, while performing the insertion sort, the first thing we encounter is the for loop. So here you can see this for loop goes from I equal to 1 and it goes till I is less than n. So friends, in our previous lecture we discussed that when we perform insertion sort, we usually divide the array into two parts. One is the sorted part and the other is unsorted part. So here you can see that when we start sorting this array, all the elements are in unsorted part and no element is in sorted part. So what we do is we simply pick one element which is the first element of the unsorted part. So let's say we pick 5, and as soon as we pick 5, as 5 is the only element which we want to sort, therefore we directly place 5 to the sorted part because we don't have to compare 5 with any element. So instead of doing this stuff, we directly start from I equal to 1, which is this position, because 5 is already sorted into its correct position. So usually this algorithm starts from I equal to 1. So here you can see that 5 is in sorted part and all other elements are in unsorted part. So we always start from I equal to 1. And as I having value as 1 is less than 5, therefore the condition in for loop comes out to be true. So friends, here when we perform insertion sort, one rule of thumb is we always pick the first element of the unsorted part and we try to put it in sorted part by comparing 1 with all the elements in the sorted part and placing it into its correct position. So when we perform this comparison in the sorted part, all the elements which are larger than this first element, we simply shift them by one position so that there is an empty space where we can simply put this element. So here you can see the space are already occupied with some numbers. So when we perform a shift, there can be a chance that some numbers can be overridden. So what we do is we simply store this value which we want to compare with the elements in the sorted part. We simply store it into a temporary variable. Here, moving ahead. So friends, now we want to compare this element with the elements present in the sorted part. So here you can see, as we have picked the first element of the unsorted part, if we go one position back, we will get the elements of the sorted part. So we simply do I minus 1, and to access the elements of the sorted part, we simply store it in the j variable. So here j becomes 0. So usually the elements of the unsorted part are accessed via I and the elements of the sorted part are accessed via j. So friends, now we provide a while loop because we want to compare this element with each and every element in the sorted part, and all the elements which are greater than this element, we simply shift it by one position so that there can be a space where we can simply put this element. And as we are sorting this in ascending order, So here the condition we provide in while loop is that j should be greater than equal to 0, because inside this while loop we are decrementing j by 1. So we have to provide this condition that j should be greater than equal to 0, because we don't want to go outside of this array. And also why we are decrementing j by 1 is we need to compare this element with each and every element in the sorted part, so that we can put this element into its correct position. So the first condition is j should be greater than equal to 0. So here j is equal to 0. Therefore this condition comes out to be true. And then we provide one more condition as the element at jth index is greater than temp or not. So here you can see the value of j is 0. So the element at index 0 is 5. And here you can see 5 is greater than 1. So we know that as we are sorting this array in ascending order, 1 should be placed before 5. So therefore this condition in while loop comes out to be true. And we want to find out the correct position of 1. So what do we do is, in the first step, as 5 is greater than 1, and as we discussed in our previous slide, that all the elements which are greater than 1, we have to shift by 1 position. So how we perform shift is, as we have already stored 1 into this temporary variable, therefore it's like a hole here, and we can shift 5 here. So we simply assign the value stored at jth index, which is 5, to value at j plus 1th index. So j is 0 and j plus 1 is 1. So we are simply storing 5 to this place. So here now 5 has been shifted to this position. And after this shift we simply decrement j by 1, because now we want to compare 1 with an element just before 5. So we simply decrement j by 1. So as j is 0, j becomes minus 1. So here it means that now j is pointing to minus 1, which is an index which is out of this array. So friends, as here you can see that in our sorted part there was only one element, 5. So we compared that element with 1, and there are no more elements to compare. So therefore this condition where j is greater than equal to 0 comes out to be false, because j is equal to minus 1. So the condition in while loop comes out to be false, and while loop exits. And at the end we have found a position where we need to store 1. So that position is j plus 1, because as j is pointing to minus 1, so it means j had traveled till minus 1 position to basically shift the largest elements by 1 position. So when we do j plus 1, here we are simply storing the value 1 at index 0, because as j is minus 1, j plus 1 becomes 0. So we are simply storing 1 at 0th index. So friend, after performing this all steps, now here you can see that 1 and 5 are basically two elements which are sorted. So therefore with each for loop iteration we will get one element which will be now part of the sorted array. So here now 1 and 5 are part of sorted array, and rest of the elements are part of unsorted array. So here now we'll increment I by 1. So I becomes 2. So friends, as we already discussed, that we simply pick the first element of the unsorted part in order to make this element to be placed in its correct position in the sorted array. So we simply start with storing the value at ith index into a temporary variable. And why we are storing into this temporary variable is because we want to create a whole year. So moving ahead, now in order to access the sorted array, we simply do I minus 1. So the value of j is 1. In while loop, we simply check whether j is greater than or equal to 0 or not. So j is greater than 0. So this condition comes out to be true. And then we simply check that the value stored at jth index is greater than temp or not. So here you can see value of j is 1. So the value at first index is 5. And 5 is not greater than 9. So therefore this condition comes out to be false. And the while loop exits. So here you can see that as we are sorting this array in ascending order, we want a correct position for 9 in the sorted array. So as there are only two elements which are sorted, 1 and 5, when we compared 9 with 5, we found that 5 was not greater than 9. So therefore the correct position of 9 would be after 5. So here this while loop exits, and at the end we simply store the value 9 in the array at j plus 1th index. So value of j is 1. When we do plus 1, we get 2. So we simply store the value 9 at index 2. So now here you can see the three elements 1, 5, 9 are properly sorted. So therefore 9 will be now part of this sorted array. We increment I by 1. I becomes 3. And now we simply pick the first element of the unsorted array. So we simply store the value 2 into a temporary variable. Because now we want to place this 2 into its correct position in the sorted array. So when we'll perform these steps, we need to shift some of the elements by one position so that we can place 2 to its correct position. So when we'll shift these elements by one position, we need to create a space here. So what do we do is we simply store this value somewhere into the temporary variable, because we need to refer this while comparing it with the elements in the sorted array. So in order to access the sorted array, we simply do I minus 1. So j will keep the track of the sorted array. So now we'll perform the comparison. We'll see that j is greater than or equal to 0. So value of j is 2. Therefore this condition is true. So now we'll compare this 2 stored in this temporary variable with the element stored at jth index, which is 9. So here you can see 9 is greater than 2. Therefore the condition in while loop comes out to be true. And as 9 is greater than 2, we know that 2 must come before 9. So for 2 coming before 9, we need to create a space here. So what do we do is, we simply shift this value by one position by storing the value at jth index into j plus 1th index. So j is 2. So this value 9 we are storing in j plus 1th index, which is the third index. So 9 comes here with a shift. And as we have already stored this value at temporary variable, we can override this part. So 9 goes to the third index. So now we have compared it with 9. So we simply decrement j by one position, because there can be more elements which can be greater than 2. So j becomes 1. And as j is greater than 0, this condition comes out to be true. and the value stored at jth index, which is 5, is also greater than 2. Therefore, the condition in while loop comes out to be true. And we simply shift phi by 1 position by assigning the value at jth index to value at j plus 1th index. So we are simply shifting phi by 1 position because value of j is 1. So this value we are assigning it to j plus 1, which is the second index. And then we'll decrement j by 1 because there can be more elements which can be greater than 2. So j becomes 0. Now whereas j is greater than or equal to 0, this condition comes out to be true, but the value stored at jth index, which is 1, is not greater than 2. Therefore we know that this value 2 will be stored somewhere after 1. And as we have already shifted phi to its correct position, this position is actually a space where we can store 2. So here this condition comes out to be false. And at the last step, as j is pointing to 0, we know that we need to store 2 after 1. So we simply store this temp value to j plus 1th index, which is the first index. So 2 comes here, which is actually 2's correct position. Now after this for loop ends, 1, 2, 5, 9 will become part of the sorted array. We'll simply increment I by 1. So I becomes 4. And now we simply want to put 10 to its correct position in sorted array. So we simply store 10 into this temporary variable. Moving ahead. So now as we want to compare the value stored at temporary variable with the elements in sorted array, we need to access the sorted array. So we simply do I minus 1 and we store it into j. So j becomes 3, which is the last element of the sorted array. So as j is greater than or equal to 0, this condition comes out to be true. But the value stored at jth index, which is 9, is not greater than 10. So therefore this condition comes out to be false. And we simply store this value 10 in this array at j plus 1th index, because 9 is at its correct position, and as it is less than 10, therefore 10 should be stored just after that. So we simply store 10 to j plus 1th index. So friends, here you can see that now 10 will also be part of the sorted array, and as there are no more elements left to be compared, because when we increment I by 1, I becomes 5, and as 5 is not less than 5, therefore the condition in for loop comes out to be false, and this for loop exits. So friends, here you can see we have sorted this array into ascending order, storing in the form as 1, 2, 5, 9, 10. So friend, in this lecture we discussed about the insertion sort algorithm by demonstrating the algorithm step by step, where we actually divided the array into two parts, the sorted part and the unsorted part. And with each iteration, we picked the first element of the unsorted part and we compare this element with each and every element in the sorted part to place the element into its correct position. And how we place the element in its correct position is by shifting all the larger elements which was greater than this first element of the unsorted array. So friends, this is the demonstration of the algorithm step by step. Now let's go to Eclipse and see the implementation of this algorithm and its working. I hope you like this video. Thanks, have a nice day.